Welcome to Target IS. I am Prakash Rajput, and today we will see some numericals which on which we have what we have learned in the previous classes. So here is one first numerical. It says that two identical conducting spheres A and B carry equal charge. Carry equal charge. They are separated by distance much larger than their diameter, and the force between them is F. Force between them is F. A third identical conducting sphere C, which is uncharged. Sphere C is first touched to A and then to B, and then it is removed. As a result, the force between A and B would be equal to how much from the given option. So we have to find the force after the sphere C has touched A and B. So let us first understand what the problem is here. Let us first understand that here there are two charges which are having equal charge on them. Suppose this is my conducting sphere A, conducting sphere B, and both are having charge Q, and they are separated by a distance which is much larger than their radius, so they can be considered as point charges only. So magnitude of force which is acting on them by Coulomb's law is kq square divided by r square, as you know it. So this is it. Now what happen is a uncharged sphere is brought and it is touched to A. So two when two these bodies touch, when these two are in contact, there is charge distribution starts to happen by transfer of charge. By transfer of So here charge distribution takes place by transfer of charge, and it continues till both are having equal charge, because identical they are identical conducting spheres. So suppose this sphere is C and this sphere is A. It was having charge Q. Now what will be the charge on each sphere? Will be charge on each sphere after they are in contact will be their mean, that is their average. So charge on C was 0 because it was uncharged. Charge on A was Q divided by 2. So charge on each sphere will be Q by 2. So we can say that QA becomes, charge on sphere A will become Q by 2. It was having previously Q charge, now it is having Q by 2. Now also QC is also Q by 2, because both are having equal charge. Now this conducting sphere C is brought in contact with sphere B. Now it is having charge Q, it is having charge Q by 2, and you know that when the two conducting spheres are in contact, charge distribution happens by the transfer of charge. So charge on each sphere, in this case charge on each sphere will be their average again, so it will be Q by 2 plus Q divided by 2. So it comes out to be 3Q by 4. It comes out to be 3Q by 4. So we can say that QC will be equals to QB, and this will be equals to 3Q by 4. Now what the problem says is find the force between A and B after this has happened and the charge C is sphere C is removed. So now here is suppose this is my sphere A, this is my sphere B. Now what is the charge on them? It is having Q by 2, it is having 3Q by 4. So what will be the force? They are now also they are at same distance only. So what will be the magnitude of force? It will be, suppose this is F1, so it will be K product of charges Q by 2 into 3Q by 4 divided by distance is same as R, it will be R square. So what it becomes? KQ by R square kq by r square into 3 by 8 into 3 by 8, this 3 and 2 into 4, 8. So I can write this as 3f by 8, because this term is nothing but the previous magnitude of force, previous magnitude of force. So this is the force acting now between these charges. So from the given option, which option will be correct? If you see here, this option is actually 3f by 8. So this option is correct option. So 3f by 8 is the correct answer. Now see here another question, which is a charge of plus 10 coulomb is located at these coordinates, and charge of minus 5 coulomb is located at these coordinates, x equal to 0, y equal to minus 1. So find the point on the y-axis at which electric field is 0. Find the point on y-axis at which electric field is 0. So let us first place the charges in the coordinate system. So here only x and y coordinates are given, so no problem with z. We can simply take here x-axis, here y-axis, and also there is not much requirement of x-axis also. The first charge is at y equals to x equal to 0 and y equals to 1. That charge is plus 10 coulomb, and another charge is present at y equals to minus 1, x equal to 0 is minus 5 coulomb. So what is the value of the point y we have to find, at which the electric field is 0? So we can find, suppose let us take one point on the y-axis at which electric field is 0. Suppose I am assuming that the point lies anywhere you can take, suppose point lying here. So this is having coordinates 0 comma y, obviously, so because it is on y-axis. So what will be the electric field due to this at this point? It will be 1 by 4 pi epsilon naught into the charge is 10 divided by what is the distance from here to here? It will be, if you find the vector form, so it will be field location minus field location minus source location. So 0 minus 0, ax component is not required, ay component will be there only. So y minus 1, so it will be y minus 1 whole square, and direction, what the direction will be? It will be in the direction of negative, minus ay cap, minus ay cap, because it is positive charge. So the electric field due to this will be from positive, so it will be radially outward, so it will be in the decreasing y direction. So this will be the electric field due to the first charge. Suppose this is E1. Now let us find E2 due to another charge. What it will be? 1 by 4 pi epsilon naught into what is the charge? It is minus 5 divided by, if you find the y minus location is field location minus source location, so 0 minus 0, 0, y plus 1, here y plus 1 whole square. And what will be the direction of electric field? It will be in the downward direction, so it will also be minus ay cap, it will also be minus ay cap. So now we are taking electric field at this point as 0, so we can say that E1 plus E2 will be equals to 0. So E equals to 0 equals to E1 plus E2. So I can write now E1 is 1 by 4 pi epsilon naught into 10 by y minus 1 whole square minus ay cap plus 1 by 4 pi epsilon naught minus 5 divided by y plus 1 whole square minus ay cap equals to 0. So you can take some things common like 1 by 4 pi epsilon naught. Here it is 10, here it is 5, so 5 can be taken out. So what it will be now, here they see minus and minus will become plus, so this term will become plus, and I can write 1 by y plus 1, as there is only ay component. So I will take, I will not write it now. So y plus 1 whole square, and all the things I have taken out and they are gone in the right sides and become 0. Here what is remaining? Minus 2 by y minus 1 whole square equals to 0. Now simply just solve these equations. It will be, you have to just apply now maths. So here it will be y minus 1 whole square minus 2y plus 1 whole square equals to 0. And you can do now, uh, opening this, y square plus 1 minus 2y, so here minus 2y square minus 2, and minus 4y equals to 0. So it comes out to be minus y square, here it will be minus 6y, and this will be minus 1 equals to 0. So this is a quadratic equation. If you solve this, you will get two solutions. You will get two solutions, and what those two solutions are: y equals to minus 0.17 minus 0.1716, and y equals to minus 5.83. It is 828. I will write as 5.83. So these are the 2 points at which the electric field is 0. So what I have taken? I have taken here this point. So somewhere on the y-axis, if I extend this, somewhere on the y-axis, here, here also the electric field at the 5.83 point will be 0. So this is the solution for this question. Now what happened by why there are 2 points of where electric field is 0? So here it is positive charge and here it is negative charge. So what will be the direction of electric field due to this? It will be in this direction, and for this, here it will be inwards. For the negative charge, it will be towards, if I say ay cap, in the ay cap direction. So that's why if this field extend further, here due to positive charge direction of electric field is this, and due to negative charge direction of electric field is this. So there will exist some point at which these two electric fields are equal and they will cancel each other. So that's why this is the point where this electric field is cancelling each other and becoming 0. Let us see our next question. Here, an infinitely long uniform charge of density 30 nanocoulomb per meter is located at location y equals to 3, z equals to 5. The field intensity at 061 coordinates is this much. So what is the electric field intensity at this location in terms of this value? E के terms में आपको आंसर बताना है इन ऑप्शंस में से. So first of all, we have to just understand where our line charge is present. So here it is said that its coordinates are y equals to 3, z equals to 5. What you understand by this y equals to 3, z equals to 5 is it is parallel to the x-axis. If I show in the, here it my x-axis, here it is my y-axis, and here it is my z-axis. So what are the coordinates for the line charge? Y equals to 3, z equals to 5. So it is somewhat here. It is somewhat here. If I show, it will be parallel with the x-axis, somewhat like this. This is my line charge. So the field at location 061 is given. 061 is given. Field at location 061 is given. तो 061 कहाँ पर होगा? Y की value 0. So somewhat here. Now we have to find the electric field at this point 561. So where will be 561? It is in this direction, or because it is the positive x direction. So here the value of x is 0, 1 2 3 4 5 ऐसे इंक्रीज करते हुए x में आप बढ़ रहे हो. तो अगर आप देखें, अगर आप 3D फिगर इसको इमेजिन करें, तो ये जो डिस्टेंस है फ्रॉम द लाइन will be same for both these points. I have told this point earlier also कि लाइन चार्ज के केस में अगर x के पैरेलल है और सिर्फ x का कोऑर्डिनेट चेंज करा आपने, तो इलेक्ट्रिक फील्ड सेम रहेगी. अगर आप 061 पर देख रहे हो, 161 पर देख रहे हो, 561 पर देख रहे हो, 861 पर देख रहे हो, सिर्फ और सिर्फ x का कोऑर्डिनेट आप चेंज कर रहे हो, y के कोऑर्डिनेट 6 और 1 ही रहने दे रहे हो, तो जो इलेक्ट्रिक फील्ड यहाँ पर है वही इलेक्ट्रिक फील्ड यहाँ पर भी होगी, because it is independent of the value of x, because it is parallel to the x axis. So we can simply say the answer is a option. अब ये बाकी ऑप्शन देख करके ऐसा लग रहा होगा बहुत ही खतरनाक टाइप का क्वेश्चन है, बट इट वाज अ सिंपल क्वेश्चन. सो यू हैव टू जस्ट थिंक ऑफ इट. होप यू अंडरस्टूड इट. Moving on to our next question. So this is our next question. Here two infinite sheet of charge density 10 nanocoulomb per meter square and minus 10 nanocoulomb per meter square are located at x equal to 0 and x equals to 10. Find E everywhere. Everywhere का मतलब कि x इक्वल टू 0 के राइट में, लेफ्ट में, x इक्वल टू 10 के 0 के राइट में, लेफ्ट में, हर जगह पर इलेक्ट्रिक फील्ड पता करिए. तो हम बना लेते हैं कि x एक्सिस बना लेते हैं. ठीक है, तो x एक्सिस पर चार्जेस को प्लेस कर देंगे. तो सपोज दिस इज माय x एक्सिस and it is having a 0 point here. So first plate is placed here, x equal to 0. It is a surface, not a line. So if you imagine the 3D figure, it is x equals to 10. So if I show like this, and one more surface charge which is present at x equals to 10, one more surface charge which is present at x equals to 10, they are infinite surface, so there is no limit for height actually. Now this surface charge density is 10 nanocoulomb per meter square, and for this minus 10 nanocoulomb per meter square. This is at x equals to 0, this is at x equals to 10. Now you have learned that for an infinite surface the electric field intensity is given by rho s by 2 epsilon naught and in the direction of जिस भी डायरेक्शन, जो पॉइंट के ऊपर डिपेंड करेगा कि किस डायरेक्शन में है वो. ठीक है, तो सपोज वी आर फाइंडिंग इलेक्ट्रिक फील्ड between this region. So what is this region? It is from 0 less than or equals to 10. तो इस रीजन में इलेक्ट्रिक फील्ड निकालते हैं. अब ड्यू टू दिस इज a positive charge, so what will be the direction of electric field? This is x axis, so it is in the direction of ax cap, and this is negative charge, so for this electric field will be inside the inwards होगी इसके लिए. So what happens here is both the electric fields are getting added. Both the electric fields are getting added. So in the region 0 से लेकर के 10 के बीच में जो इलेक्ट्रिक फील्ड है वो क्या है, रो एस बाय टू एप्सिलॉन नॉट प्लस रो एस बाय टू एप्सिलॉन नॉट in the direction of arrow cap, in the direction of as I get as it is given that it is in the direction of x, so we can write it as ax cap. Now rho s is given. What is rho s? It is 10 nanocoulomb. So I can write it as 10 into 10 ki power minus. We can simplify this first. So rho s by 2 epsilon naught and rho s by 2 epsilon naught will become rho s by epsilon naught ax cap. So here 10 to the power minus 9 divided by 2 into epsilon naught value is 1 by 36 pi into 10 to the power minus 9. This can gets cancelled. Here this value gets cancelled. Here this is actually pi. So what is remaining? 18 into 10. So it is 180 pi ax cap volt per meter. You should remember the units. So in between the plates the electric field is 180 volt per meter. Now what can you say about for this surface here from 0 to minus infinity? Now you can see that electric field does not depend on the distance. So for this surface the electric field direction will be in minus ax cap, will be in direction of minus ax cap. And for the negative surface charge density the electric field direction will be in this direction. So here this is rho s by 2 epsilon naught and here it is rho s by 2 epsilon naught. Both will actually cancel each other, so electric field here will be 0. And similarly here also from x equals to 10 to infinity, if we see the electric field direction for this negative surface charge will be in this direction, it is minus ax cap, and for this surface it will be in the this direction. So this is minus ax cap, this is plus ax cap, and the value will be same rho s by 2 epsilon naught for both the fields, so they will also cancel each other. So what is electric field here also? It is 0. So the only electric field present in this region which is between the plates. So this is the solution for this question. The electric field is present between the plates is 180 pi. We have solved it in the direction ax cap positive to negative, and other than that everywhere electric field is 0. You can also take uh, both both the charges, both the surface charge as positive or both the surface charge as negative, and do an exercise and find the electric field everywhere. You will know uh, where will be the electric field present and where it will be not. Now moving on to the next question. Now see another question. Two infinite sheets of uniform charge density rho s equals to 1 by 6 pi nanocoulomb per meter square, and they are located at one y equals to minus 5 and the second at z equals to minus 5. Determine the uniform line charge density rho L that will produce the same value of electric field at the location 422 if line charge is at y equals to 0 and z equals to 0. So you have to find the line charge which will produce the same electric field as the surface charges are producing. So if you see the surface charges are present in the xyz plane, xyz coordinate system, not plane. So here it is x-axis, it is y-axis, and here it is z-axis. So the first surface is present somewhat here at y equals to minus 5, another surface which is present at z equals to minus 5, somewhat here. This is z equals to minus 5 surface, z equals to minus 5. So what will be the direction of electric field due to this? It will be ay cap, and for this it will be az cap, because it is given that it is positive only. So we can write the electric field at this location due to these surface charges, where this location will be present 422. It will be in the in this somewhere here. So ay cap, az cap, and adding both of them, so it will be rho s by 2 epsilon naught ay cap due to the y equals to minus 5 surface, and due to y equals to minus z equals to minus 5 surface, it will be rho s by 2 epsilon naught az cap. You can take this out, rho s by 2 epsilon naught ay cap plus az cap. This is the value of E due to the surface charge density. Now what we have to find is the line charge which is placed at y equals to 0, z equals to 0, and it is producing same electric field at that point, which was 4 comma 2 comma 2 at this point. So the line charge will be on the x-axis because its coordinates are y equals to 0, z equals to 0. So if you remember the formula for the infinite line charge, the value of electric field is given by, to join this, so this vector I can say r vector. So what was the formula for the electric field due to infinite line charge? It was rho l divided by 2 pi epsilon naught 1 by r vector magnitude square, and in the direction of r vector. So what is that r vector here? So this is actually perpendicular distance, so you can directly find this by field location minus source location. So what is the coordinate for this? It will be x and 0 and 0, because y and z are 0. So x value won't matter here, so the r vector will become 2y cap plus 2z cap, 2ay cap plus 2az cap, and the magnitude becomes under root of 2 square plus 2 square, that is root 8. So if I put the values here, rho l by 2 pi epsilon naught, what it becomes here, root 8 is the magnitude, and here it is square, so it becomes 8. And here r vector, so r vector is this, I can take 2 outside, I can write ay cap plus az cap, 2 into ay cap plus az cap. Now this electric field has to be equal to the electric field produced by the surface charge, so I can equate these two electric field. So equating the two electric field, the first one was rho s by 2 epsilon naught ay cap plus az cap. You can see rho s by 2 epsilon naught into ay cap plus az cap. So here ay cap plus az cap, and due to the line, it is rho l by 2 pi epsilon naught 1 by 8 twice of ay cap plus az cap. You can see here this rho l by 2 pi epsilon naught 1 by 8 into 2 ay cap plus az cap. So there are many things which are cancelling here, you can cancel them. So this is first which is cancelling, here epsilon naught gets cancelled, and here this 2 gets cancelled with this, and few more things we can simplify. So simplify this and write rho l is equals to, and take all the things here, so it will be rho s into pi into 8 by 8 by 2, rho s into pi into 8 by 2. So what was the value of rho s? Rho s was 1 by 6 pi nanocoulomb per meter square, where it is here 1 by 6 pi nanocoulomb per meter square. So after putting here 1 by 6 pi into 8 divided by 2, this comes out as 8 by 12. So the value of rho L is, it is in nanocoulomb per meter actually, so value of rho L is 0.667 nanocoulomb per meter. This is the value for of rho L that will produce the same electric field at the point 422, which was produced by the surface charges present at y equals to -5 and z equals to -5. Now moving on to the next question. So now this is our next question. It is, calculate the force on a point charge of 50 microcoulomb present at 005 due to charge of 500 microcoulomb, which is uniformly distributed over a circular disk of radius 5 meter and placed in xy plane with center at origin. Now if you remember, we have done the derivation for the electric field due to a charge disk on its axis. So this problem is based on that derivation only. So if you apply the direct formula also, you can get the answer. First we have to find the charge density. So the charge density is charge divided by area of the disk. Area of disk. So what is the charge on the disk? It is 500 microcoulomb divided by area of the disk. So it is a circular disk, so area of the disk will be pi into the radius square. So radius of the circular disk is 5. So here 5 square. If you simplify this 5 square is 25. So 2, and it will be 20 to the power -6 divided by pi. This will be the surface charge density in coulomb per meter square. Now, what was the formula for the electric field due to circular disk? It was rho s by 2 epsilon naught 1 minus z by under root of a square plus z square az cap az cap. So what is the value of rho s? It is this 20 to the power -6 divided by pi into 2 into epsilon naught value is 1 by 36 pi to the power -9 10 to the power -9, and this gets multiplied with 1 minus z. Z is basically the height at which we are calculating the electric field. So z is this 5. So here it is 5, and what is a? A is the radius, which is 5. So it's 5 square plus 5 square in the direction of az cap. So if you simplify this, you will get the answer as 1054.156. This will be the electric field in volt per meter. Now, what was the question actually? It was saying that calculate force on this point charge, but what we have calculated is electric field at this location. So using this electric field we can find the force. If you remember the alternative forms of Coulomb's law, what was that? Force is equals to charge multiplied with electric field. This was the alternative form of electric field. So in case of electric field, the force can be calculated like this also. because this was a surface charge, so we cannot directly apply the Coulomb's law like 500 into 10 to the power minus 6. So and kq by r square, that formula won't work here. So we have to go by this process only. We have to find the electric field at that point, and then we can simply calculate the force. So what was the charge given for which we have to find the force? It was 50 microcoulomb. And what is the electric field we have calculated? It is 105,441.56. So if you solve this, the direction is az cap. Yes, obviously the direction is az cap. Here also it is az cap only. So what the force becomes, if you solve this, it becomes 5.27 5.27 az cap newton. This will be the force on this small charge of 50 microcoulomb due to this circular disk. So this is the question. Now next question. Now the next question is 825 nanocoulomb charges 825 nanocoulomb charges are located in free space symmetrical on a circle of radius 0.2 meter centered at origin in the z equals to 0 plane. At what point on the z axis magnitude of E, यानी कि electric field, is maximum? And what is that magnitude of maximum E? So what the problem says is there are 8 point charges which are located in free space. Suppose this is my z axis and this is my x axis, and here is my y axis. So the charges are placed like in a circular pattern. So there are 8 charges which are symmetrically placed. There are 8 charges which are symmetrically placed. 1, 2, 3, 4, 5, 6, 7, and here 8 charges which are symmetrically placed of radius, and its radius is given as 0.2 meter. So what we have to find is electric field is maximum at a certain point. Electric field is maximum at a certain point. What is that point on the z axis? So electric field, at this point the electric field is maximum, and this has a coordinates of 0 0 z, because it is on z axis. So what we can do is we can find electric field due to all these charges and add them with the help of superposition principle which we have learned. So what I will do is I will simply apply the superposition formula, that was E is equals to 1 by 4 pi epsilon naught summation of all the charges, where I is equals to 1 to 8 charges are present, and Q can also come out because each charge is of equal charge. So Q by 4 pi epsilon naught, what remains is 1 by R12 vector magnitude cube and the direction of R12. So as the charges are placed symmetrical, so this distance will be same for all the charges, and they will have one component in z and one component in rho direction, as you have seen for a circular pattern. Because if I take this charge and electric field due to this in this direction, it will have one in the z direction and one in the rho direction. एंड सिमेट्रिकली अपोजिट ये वाले चार्ज की वजह से इलेक्ट्रिक फील्ड होगी इधर, और एक होगी जेड डायरेक्शन में इधर। दैट तो ये जो जो ये जो रो कंपोनेंट है वो तो कैंसिल होने ही वाला है, ठीक है। तो आपको इलेक्ट्रिक फील्ड निकालनी है सिर्फ और सिर्फ जेड डायरेक्शन में ही होनी चाहिए वैसे भी वो, तो उसका ही मैग्नीट्यूड निकालना है कि वो कब मैक्सिमम होगा, ठीक है। तो यहाँ पर वैल्यूज पुट करते हैं, लाइक सो यू नो दैट दिस will be same for all here. So what I can take is r1 as r12, what I can take here is r12 r12 equals to field location minus source location for all of there. So suppose this is rho and some value of phi, and the z value will be 0. So r12 will be again what it will be, minus rho a rho cap plus z a z cap, and the magnitude will be under root of rho square plus z square. For all of the charges this value will be same, this value will be same. So we can directly multiply this by 8, like q by 4 pi epsilon naught divided by 1 by r12 cube into r12 and multiply this by 8 because they are symmetrical. So I can write E equals to 8 times of q by 4 pi epsilon naught into r12 magnitudes cube. So this is magnitude, so it becomes rho square plus z square to the power 3 by 2, and the r12 vector which is having only z component, as I have told that the rho component will get cancelled because the charges are placed symmetrically and they are even number of charges, so obviously they will cancel the effect of each other. So now this is the formula. Now we have to find the maximum field, maximum value of the electric field at certain point. So for maxima आपको क्या करना पड़ेगा, फॉर मैक्सिमा मैथ्स के प्रिंसिपल इस्तेमाल करने पड़ेंगे. सो यू हैव टू डू del E by del Z, del E by del Z, because at Z point we are calculating the electric field which is maximum. So del E by Z del Z को 0 से इक्वेट करना पड़ेगा. तो इस एक्सप्रेशन को Z के रेस्पेक्ट में डिफरेंशिएट करते हैं. So del E by del Z, these things are constant, they will come out of the differentiation, and I'm taking here magnitude. So az component I'm ignoring because it is having only one component. So now I can differentiate, so it will become rho square plus z square to the power 3, and here it will be rho square plus z square to the power 3 by 2, and differentiation of z will be 1, so minus, and then z multiplied with differentiation of this. So differentiation of this will be 3 by 2 rho square plus z square to the power 3 by 2 minus 1, it becomes 1 by 2, and the differentiation of rho square plus z square, again what it becomes is 2z, and I have to equate this whole thing by 0. So you can see this component gets to the right side and 0, and here this also goes to the right side and becomes 0. So what remains is uh, you can take out this under root of rho square plus z square common also. So what is this here? I have taken under root of rho square plus z square common, so here becomes rho square plus z square, and here the value of 2 gets cancelled with this, and this z gets multiplied with this, so it becomes 3z square, it becomes 3z square, and equating this to 0. Now you see this can't be 0, this cannot be 0, so only thing which is possible is rho square z square minus 3z square becomes 2 minus 2z square, minus 2z square equals to 0. So what is the value of z square is, it is rho square by 2, and the value of rho was given in question as 0.2. So I can place this value there. So it is 0.2 square divided by 2, and after solving this I will get plus or minus 0.1414 meter, because it was in rho was in meter, so it will also be in meter. Now why there is plus or minus? Because it will have one point over the xy plane here, like on the positive z axis, and also it will have one more point in the negative z axis at same distance. That's why the plus minus is there. So this is the answer to the first question, that is what is the point. So point हम बता सकते हैं z axis पर है, तो क्या होगा वो point 0,0,0.1414, ठीक है, यहीं पर प्लस और माइनस लिख देते हैं. तो दिस विल बी द पॉइंट at which the electric field is maximum. Now we can simplify the value of E max. So what was the formula for that? Here, this. So I have to put the value of Z only here, and we will get the value for electric field. So it is 8 into Q. Q is given 25 nanocoulomb. So 25 into 10 power minus 9 divided by 4 pi epsilon naught. I can write the value of this also, 9 into 10 power 9. And what else was Hmm, here, z by root z by rho square plus z square to the power 3 by 2. So z we have found out. So what is z? Z is, because it's magnitude, so I will take only positive sign. So 0.1414 and 0.1414 square plus 0.2 square to the power 3 by 2. And if you solve this, you will get the electric field magnitude as 17.32 kilovolt per meter. This will be the value of maximum electric field present on the z-axis due to this combination of 8 charges which are present symmetrically on a circle. So this was the solution for that. So that's all for today. We will meet in the next lecture and we will start new topics, electric flux, and we will see Gauss law. So thank you.